So if you're sitting at home, I forgot to start the recording, you only missed the first slide. I was showing kids that the equation from a circle comes from distance formula, which came from Pythagorean theorem. And we just filled in those notes. And we're going to skip that. And we're going to skip that. And we're going to go straight to graphing. So we're supposed to graph this equation x minus 4 all squared plus y plus 1 all squared equals 9. Ms. Brooks, can you tell me the center? Bryce, can you give me the radius? 3. That went hard. 1, 2, 3, 4, fall 1. And from that center, what do we do? Up 3, down 3, left 3, right 3. I always do tick marks as I count. Like I know I gotta go down 3, so I'll put on 3 tick marks. And I'm gonna go up 3. 1, 2, 3, back 3, right 3. Usually my circles end up looking like ellipses. That's what happens in a freehand graph. Does anybody have any questions about how you graph a circle given an equation in STD form? Shouldn't, but if you do, it's okay. I'm too tired to make up something witty and insult you. So it's a good time to ask. Fair enough, moving on. This one says for this circle, find its intercepts. I guess it's worth doing. It's not a hard skill. There's kind of 2 intercepts you go after. You go after x-intercepts and y-intercepts. Those are intercepts. How do you find your x-intercepts? I'm waiting. No, y equals 0. So everywhere you see a y, what's it become? You crank out the math. It's not that hard. Some kids really get confused. I write this step and they're like, I don't know what to do. Well, you add 0 and 1, and you get 1, and you square that 1, and you get 1. You got to see all the work. You have a line that looks like this next. How are you going to do that one? You take it away from 9 and get an 8. And how are we going to counteract squaring? Square rooting. It's not hard. None of this stuff is. There's kids that literally think this is just some weird stuff that we do, and it's really not that weird. We just do opposite of everything we see. Unless there's actual numbers that we can do math with. We do what tells us good. Root of 8, simplify it. 2. You love pandas? Plus or minus. Hey, you remember. Anytime you're dealing with a square, you better include plus or minus. All right, what do we add to both sides? 4. So 4 plus or minus 2 root 2. So here's our x-intercepts. We have a 4 plus 2 root 2. We have a 4 minus 2 root 2. I'm writing out the order of pairs. Both of those x values happened when y was what? 0. Okay. While you're catching up, I'm going to drink some more energy drink. Maybe by second period, I'll be good and wired. When these things first came out, kids were like, Mr. Milbrath, what about your heart? What heart? What are you talking about? All right, anybody any questions on that? All right, what's left to find? Y-intercepts. Really get it up for me. Actually, how do you find a y-intercept? Brendan says let x equals 0, well, nice and quiet. And this is basically going to be the same exact steps and procedures. It's a little bit different. It's not going to be hard to do. So we're going to do a 0 minus a 4 squared plus a y plus a 1 squared equal to a 9. And we square that 0 minus 4 piece, we're going to get a 16, aren't we? We're going to take that 16 away from 9, and what's going to happen? You get negative 7. If you know what you're doing, you need to stop right there. Why do you need to stop right there? Imaginary, that's right, Bryce. It says imaginary answers. Is there, or are there, y-intercepts? No, there are no y-intercepts. No real y-intercepts in those. Now, I think we graphed that equation just a minute ago, didn't we? Just look back on your previous slide. Pretty sure that's the same exact equation. It is. Get across the y-axis. No. So the math supports, the graph supports our math. And that should do it for STD form. So what's up next is something we call general form. If it's not the next thing in your notes, we'll skip to it until it is. Ah, it is, general form. General form of an equation with circle looks a little bit funny. It's ax squared plus by squared plus cx plus by plus e equal to 0. Where a equals b and a and b are not 0. That's general form. General form is pretty much worthless. You can't look at it and know what to do. Not that it's worthless, it's that you cannot look at it and figure out what to do. So anytime we see an equation with general form, the idea is we convert to standard. Convert to standard form by a very old technique, a 6,000-year-old technique. Anybody know what technique I've told you is about 6,000 years old? Babylonians are credited with coming up with it. Completing the square. Twice. If you know how to complete the square, it's not hard to do. It's really not. All right, so we're supposed to graph this thing. Now I'm going to write off the steps on the side here. Step 1 would be divide all terms by A if A is, well, by A. Just leave it as that. You find A by looking at x squared and y squared because they're supposed to match. What's A? 1. Now, I actually introduced a second step here. Group your x's and y's. While you're at it, go ahead and move that constant to the other side. Some kids get really, really good at completing the square, and they don't need to show all the work. Like if I wanted to complete the square on x squared minus 16 minus 8x, I would just add 16. If I wanted to complete the square on y squared plus 4y, I'd just add 4. I'll kind of show you why, and then I'll explain what's going on if you need to see it. I had 16 here. That factors is x minus 4 squared. Now, if I had 16 on the left, I better add 16 on the right. If I add 4 here, how does y squared plus 4y plus 4 factor? Y plus 2. This is how I was taught. I mean, I was taught, just think about what you need to add. But we also grew up not punching buttons on a calculator. We were expected to be pretty good with numbers. So we were just taught stuff like this. There wasn't no set of 8 things that you do. Just think about how it factors. That's how we were taught. And if I add 4 here, I better add 4 here. That would be 21 and 25. Now, when you talk about what I did a certain thing. I'm not going to call it a letter of the alphabet. I took half of what was in front of x squared it, and added to both sides. Because I took half of a negative x and I got a negative 4, and I squared it, I got that 16 and I added to both sides. And I did the exact same thing for y, didn't I? I took half of a positive 4, because there's a 4 in front of y, squared it, got 4, added to both sides. I don't know why it says took, you take. And the last thing I did is I factored the grouping of x's and y's as perfect squares. And now, that thing is graphable. I'm not going to waste your class time graphing it, but if we were to graph it, where might our center be? 4, negative 2. And what might our radius be? Saying 5? Well, maybe it's just me, but I don't think that's hard. It could just be me. I'm well aware that some kids struggle. I am. Well aware. Is this the last thing in your notes? Using a graphing utility to graph a circle. Let's see. Emily, you were trying to do this, weren't you, to check your equations? Yes, she was. And then we just kind of pointed out Desmos can do everything. You know how that went?
Well, you can actually use a graphing utility to graph a circle. If you think about your TI-84 faceplate, though, all you have at your disposal on a TI-84 is y equals. You don't have y squared equals, you don't have x squared equals, you have y equals. That's what you have at your disposal. So to actually graph on a graphing utility other than a site like Desmos, what do you have to do? You have to do what? You have to solve for y. It's the only way to do it. It's the only way to do it. And this isn't a hard equation to do. In fact, it's way too easy. So let's make up something a little more complex because we got a little time. All right, let's do something like, I have to write this out. No, I don't. You want to do minus or plus? Plus, give me a number. 2. I was thinking you go bigger. That's squared. Got to be a plus sign in between. Minus or plus? I think I heard a minus. Minus what? 3. What do you want it equal to? Huh? 6. Something you can't take the square root of. No, that's fine. We're going to do this in a calculator, aren't we? Who cares? Doesn't matter. So we're going to solve that thing for y. It's really not that hard to do. I have taught every year I've ever taught you, I've taught isolation. I don't try and recreate. It's always about isolation. I want to isolate that. That's what I want to do. I don't want to worry about the squares. Squares are something I can worry about later on in life, but I want to isolate that. How do I isolate that?
Kids, just tell me what to do. I know you know what to do. Yeah. So then x plus 2 squared will be the other side. That's isolated. So now I want to isolate this. It's going to take 2 steps. 2 steps only. What's one step? Square roots. You know what happens on the left. Kids are very guilty of doing what they think happens on the right. You do not have any formulas, I've never written any formulas that allow you to simplify the square root of something plus something. It's never happened. Never will. You know, if it's numbers like, 4 plus 21, you can say it's 25 and do the square root. But do you know what x is? Do not think that you can break that radical apart. Do not think that you can counteract the square on the x plus 2. You can't. It's impossible to do because you don't know what x is. You cannot do anything with the right hand side. Nothing at all can be done with the right hand side. But there is one thing you have to remember. This is a square. How many answers are it supposed to be? 2. Well, you can add to both sides. 3. So minus 3 plus or minus root of 6 minus an x plus a 2 squared. Now be glad this isn't how we write equations of circles. Because that's way more confusing than standard form. It is a circle, I promise you, it's a circle. That's a plus or minus symbol. Looks kind of like an I.
So on to y equals we go. I got that 3 plus that root. Be careful about your calculator. If yours opens up a set of parentheses, make sure that you're paying attention. Now, I'm going to write this out like one that requires parentheses, in case you've got an older one in front of you. But it'll start with a set of parentheses, then you introduce another set of parentheses for the 6 minus. Parentheses around x plus 2 squared. And then you're going to have to close off the master set. The deal with parentheses is you have the same number opening as closing. So I have 1, 2, 3 opening. Oh, this calculator put an open one in for me, didn't it? There we go. Better have the same number opening as closing. Now, this calculator actually didn't require a master set inside, but some do. The other guy is the same thing, but it's 3 minus. Now I'm going to do this one without. This one keeps everything inside. And you have to exit the radical. Now the numbers you guys picked means that we'll see this on a 10 by 10 window. You will. So I guess I'll do a zoom 6. That's a standard zoom. Doesn't look like a circle, does it? You know why? Your screen is wider than it is tall. Look at the screen on your TI-84. Isn't it wider than it is tall? It's wider than it is tall. It's short and fat. Your calculator can attempt to correct for that. To zoom 5. What's it say? Square. It tries to square the window for you. Then you might see a better circle. You tend to see gaps, though. There's a reason you tend to see those gaps in the circle. Calculator just can't quite do it. But that is that, kids. Oh,
No. I was looking at your grade book and you don't have any quiz grades. So here's what you get. You get a quiz you get to take home and finish up tomorrow in class. Merry Christmas. You do have to show all your work. You do have to show all your work. If it's one of those things you do in your head, tell me what you did in your head. That's all I ask. But it's not due until you leave this room tomorrow. How many did I get you? How many did I give you one? I give everybody one? And again, the deal is, show your work. You do something in your head, like, there's problems I could do here in my head, obviously. Just tell me what you did. All right? I'm not asking for everything here. Just tell me what you did. I'm mainly thinking about number 3 on that one. You may not know how to show the work for that one. Just tell me what you did. And you'll have a quiz grade. And hopefully they'll all be hundreds. I hope. That is the question I get asked most all day long. Can I go to the bathroom? I guess if you gotta go to the bathroom, you gotta go to the bathroom.